I'm Jose Enriquez, and this is my presentation for my paper, Ethics of Reverse Engineering. So, the overview for this presentation: what is reverse engineering? What are some of its purposes and common uses? How is software protected? What is the shrink wrap license? What is clean room design? And we're going to discuss some approaches to ethics when it comes to reverse engineering. So, how does reverse engineering work? The first step is disassembling a product or piece of software in order to figure out how it works. So you can take a look at the inside, basically, take a look at the mechanics. Then you need to analyze the inner workings of the product or software, so in order to basically to know how each part works, so that you're able to apply it to your own product. And then what you try to do after that is propose improvements based on what you've learned about the product. Once you know how it works, you can figure out how you might be able to make it better, either whether it's more cost efficient, increase in performance, whatever the case might be. Some common purposes for reverse engineering can be used as a learning tool. You can learn a lot from examining either some sort of machine or software. Once you have a real life example of how something works, you can study that closely. The process is also useful for making something more cost efficient, directly because whoever is designing a copy or a derivation of the original product, well, they're spending less time in research and development, meaning that they are able to sell their new variation of the product at a much lower price. This also means that because there's more variety of products that serve the same purpose, the price of them will go down. Another purpose for reverse engineering is interoperability with more platforms. So, for example, a piece of software that is meant to work on a Windows platform, you might be able to tear that apart, retrieve the source code, and port it to, say, some sort of Mac OS in order to have it work on multiple platforms other than the one it was just designed on. Interoperability is important because there's always the possibility that a piece of software or a program or whatever kind of machine you're looking at will become outdated, or its platform will become outdated, meaning it's possible for certain programs to become lost or or unable to be retrieved. Another purpose for reverse engineering is for what's called white hat hacking, or something or anything to that effect, meaning a company can hire professionals to reverse engineering their product or software in order to find weaknesses or threats to security that the software might provide or might be exposed to. So that way the company or the original developer, whoever, can assess these threats and be able to fix them, patch them, whatever it may be, making the product more secure and reliable. So how can you protect your software? Well, you can try using a patent, but patenting software is tricky because you need to be able to prove that what your software does has an identifiable innovation. So in other words, you need to be able to prove that your software does something that no other software has done before, and that's how you're able to earn a patent for your software. So it's not very reliable. As far as copywriting goes, it's also not very reliable because you can only copyright basically the code in your software. So how the software itself works. You are not able to copyright what it does, which ties into a method for reverse engineering that we'll talk about a little bit later. But basically, copyright protects only the expression of an idea rather than the idea itself. Sort of like how you can use letters and words to compose a book. That's similar to how you can use code and methods and whatever to compose your software. Now, shrink wrap licenses. What a shrink wrap license is a end user license agreement. And sometimes what some developers do is they include a clause in their shrink wrap licenses that pretty much outright state that it is prohibited to reverse engineer the product or software that they are providing. Clean room design is a method of reverse engineering where basically one group of engineers will sort of they'll examine a product or piece of software, and they will write up a description of what the program does, all of its functionality and sort of the functionality of its mechanics. Then they'll pass on the description that only says what the program does to a separate group of engineers who have never touched the program before. They've never looked inside. And it is their job, the second group of engineers, it's their job to come up with ways so that they can make a piece of software that behaves the same way and produces the same output. So they have no knowledge of how the program actually works. So it is up to them to come up with their original ideas and come up with the same output. In this way, the reverse engineering is happening without any prior knowledge of how the software actually works, making it much more. You're able to argue that you are not copying what another software is doing. As far as approaches to ethics, a good one to argue that reverse engineering is ethical would be the utilitarian approach, which basically is about how much good something does over how much bad it does. So when we examine reverse engineering, we can examine who is being hurt and who is benefiting from the act. As far as hurting, really you're only hurting the original developer, the original company who developed the product. However, if you looked at who is benefiting, it's of course benefiting the second company, the one that's doing the reverse engineering. They're able to make a product from a prior innovation for half the cost and half the money, or half the time and half the money, or a fraction at least. And the consumers will also benefit from it because they'll have more options to choose from. They'll be cheaper now that there's more options, and so overall, reverse engineering does benefit more people than it hurts. Therefore, it would be considered ethical using the utilitarian approach to ethics. Now, the virtue approach to ethics deals more in certain characteristics of people and what kind of people they are as humans, what traits they display. So you might argue that the company doing the reverse engineering is perhaps displaying a lack of integrity or dishonesty by reverse engineering someone else's product or software. So this would be a sort of a way to show that reverse engineering is unethical and should not be done. In conclusion, it is a stronger argument to say that reverse engineering is ethical. It does benefit more people. At the end of the day, the virtue approach to ethics, it's much more subjective than the utilitarian approach to ethics. It's much more concrete. You can make solid arguments on that. And as such, reverse engineering is deemed ethical.